All right, if you will look at your Canvas, and I have posted for you the study guide for tomorrow's test. We're going to take a look at right triangles, and we're going to take a look at some of our more basic trig. One thing we will see tomorrow is both the 45-45-90 and the 30-60-90 triangle. So it's very important that you recognize the ratio between these. Remember, the sides of a 45-90 triangle are always equal. And the hypotenuse is always whatever those sides are times the square root of 2. So what we've got to consider when we're doing these things is, are we multiplying or dividing by the square root of 2? It depends on what we have. If we have the hypotenuse, we want to divide by the square root of 2. If we have the sides, the legs, we want to multiply times the square root of 2. So we can see in this one that we do have the hypotenuse. So what we need to do to convert this to a leg is to divide by the square root of 2. Guys, I want you to consider and keep in mind that this is a number. You can do this math and you can create these different things and see if it actually works. But we are not going to see an answer in this form, so you can bump the square root of 2 to the top and keep the radicand just like we have here. Now remember, radicals do not interact with non-radicals, but numbers do interact with one another. So 4 over 2 does simplify to 4 square root of 2. Now, bit of advice, when you're taking your test, check your answers. If you put this in your calculator, you're going to get an irrational number. If you put this in your calculator, you should get the same exact irrational number. If they're different, then you need to reevaluate what you've done. On this one, we have the leg of the 45-45-90 triangle, which means the other leg is equal to that. So that's an easy one right there. And notice the 5s are not reducing because one's a radical and one is not. So we need to find the hypotenuse. And the hypotenuse, remember, is equal to, we get them equal, by multiplying times the square root of 2. This is basically square root of 2 over 1, so the numerator will only be changing. So what we end up with is 7 square root 10 over 5, because the radicals do interact with one another. So the square root of 5 does get multiplied by the square root of 2, and it gives us the square root of 10. 10 is a radical, or is a number that does not reduce. We did a factoring tree. It would be 2 times 5. Nothing pairs out, so nothing gets out. So this is the simplest form of our answer. As I said earlier, we will be using 45-45-90 triangles and also 30-60-90 triangles. And we can see that this is the 30-60-90 triangle. So on the 30-60-90 triangle, remember, everything has to go through the small side. The small side is equal to half of the hypotenuse, or what we sometimes call the large side. And then if we want to go to the medium side, what we have to do is multiply times the square root of 3. So in this case, we are given the hypotenuse. So the first thing we need to do is move back and see what the small side is. So there's our hypotenuse. In order to find what the small side is, we've got to divide by 2. So 6 divided by 2 is 3, and then the square root of 3 is just tacked on. So our small side is equal to 3 square root 3. And then the way we move from small to medium is we need to multiply times the square root of 3. So since the small side is 3 square root 3, and we need to now multiply times the square root of 3, what we end up with is 3 square root of 9. 3 square root of 9, square root of 9 is 3. And remember, don't carry that radical down. Square root of 9 is just 3. So this side would be 9. One thing I would encourage you to do is to change these to numbers tomorrow to make sure that your stuff makes sense. For instance, the hypotenuse here, that is 10.39. Well, that makes sense because the hypotenuse is larger than the other side, and 3 square root 3 is equal to 5.2. So the two smaller sides add up to be greater than the hypotenuse, and the hypotenuse is bigger than the other two sides. And you can also see this is a 2-to-1 scale factor. Here's another 30, 60, 90 triangle. In this case, we have the medium side. So we need to go from the medium to the small. And the way we're going to do that is we're going to divide by the square root of 3. So we'll take our medium side, 2 square root 5, and we are going to divide by the square root of 3. Now, if you have adjusted to my bump and keep method, what we will do is we will bump the square root of 3 to join the top, and we will leave the radicand 3 in the bottom. So radicals do multiply with other radicals. So this does become 2 square root of 15 over 3. Remember, 3 and 15 do not reduce because that's not really a 15, it's the square root of 15. And this does not simplify because 3 times 5 is the only way to get 15. And neither of those pair out, so we are just stuck with the small side equal to 2 square root of 15 over 3. And I'm going to go ahead and put that as an actual number just so I can check my answers as I go to make sure everything makes sense. That's essentially 2.6. And 2 square root of 5 is essentially 4.5. So we know the hypotenuse has got to be smaller than 7.1. And let's see what this is. Next thing we need to do is move from small to large, or small to the hypotenuse. And remember, all we got to do in that case is double our number. So we're going to multiply times 2. This is easier than you think. Only the numerator gets doubled and only the number 4. Because remember, we cannot multiply times the square root, real number times the square root, so we can multiply times that integer. And again, this one does not simplify. Let's take a look and see what this number is. And remember, we already anticipate it's going to be a number below 7.1 and higher than 4.5. And it is in fact, and this is the correct answer, by the way. A is equal to 4 square root of 15 over 3, because we were asked to leave it in simplest radical form. But this is the number 5.16, so essentially 5.2. So it is larger than the medium side, and it's smaller than the other two sides combined. It's always a good sign. Another thing we're going to see is similar right triangles. One thing we've got to remember, it's been a little while since we've talked about this, but once we drop in altitude from the right angle to the bottom, we've actually created 3 similar triangles. Similar because they have equal angles and proportionate sides. So we have the large triangle, triangle 1. We have a medium little size triangle right here, and then we have a small triangle right there. But all 3 of these triangles are similar to one another in that they have the same angles, but proportionate sides. So we've got to identify what it is we're looking for on each of these. So on this first one, we are looking for the small side of the large triangle. So what we need to do is find out, okay, what do we have on each of these parts, and then develop our formulas here. So as we set up this proportion, what we need to do is identify what these parts are on their respective triangles. So in the large triangle, X is the smallest side. And on the large triangle, 25 is the hypotenuse. So what I've set up, and I'm going to just put a little note to myself, this is the small side over the hypotenuse. So whatever I set up on the other side has to be the same thing. So I'm looking for now the small triangle parts. So let's highlight our small triangle. And we need to use the same parts. So the first part that I notice is I have the hypotenuse. The hypotenuse of the small triangle is the small part of the large triangle. So I'm going to put this in the bottom down here because that's where the hypotenuse goes. And then the next thing we need to recognize is the small part, that's this, of the small triangle. Well, think about this real quick. From here to here is 25 units. And from here to here is 16 of those 25 units, which means 9 is left to be right there. And that 9 is the small part of the small triangle. So now we have our corresponding parts. We can cross multiply our values. So we have x times x, which is x squared. 25 times 9 is 225. To get the x by itself, we've got to take a square root. So we learn that our small side of our triangle, the hypotenuse of our small triangle is the square root of 225, 15. So our x value would be 15. The other thing we're going to have on here is our trig ratios. So remember our little acronym, or whatever you want to call it, the one that you're going to use. So, TOA. So as we do these, we need to first recognize what trig ratio we're talking about. Well, that's tangent. So tangent is opposite over adjacent. And then we need to find the angle of reference. So this is C. So we are going to, on this figure, find the opposite side of C, which is 36. So tan of angle C is equal to the opposite side, 36, over the adjacent side. Remember, yes, the hypotenuse is adjacent, but the hypotenuse is the hypotenuse. We don't consider that the adjacent side. So all we're asked to do on this is find the value of each trig ratio. So the trig ratio for tan C is just 36 over 27. But both of these numbers do have a common factor. Remember, you can use your calculator to reduce the factor, but these are both multiples of 9. So if I reduce this by a factor of 9, 36 would be 4, and 27 would be 3. Good news is you're not going to have 36 over 27 as a solution, so when you don't see it, hopefully that will remind you to reduce your value. Also, what we're going to see is when we are supposed to find the trig ratio. Now, let me just remind you on this. When we're doing trig to find sines and angles, we will only use the inverse trigs, that's the negative ones, when we're searching for an angle. So this one we are looking for a side, so you should not be using an inverse trig at all on any of these. So just keep that in mind as you go, and also make sure that you pay close attention to what your answers should or can be. For instance, if this is an angle of 19 degrees, that means this one is an angle measurement of 71, because that's the degrees are left. So 71 degrees is a lot more than 19. So this side of 10 better be a lot smaller than whatever I get for x. So think about that as you do these, as we work through, and as you evaluate your answer, because that's pretty important as well. So in this one, we have to choose a trig ratio, but our trig ratio is basically chosen for us because we only have two pieces of information. We have the opposite side, and we have the adjacent side. So like I said, this has been chosen for me because there's only one trig ratio that deals with opposite and adjacent, and that is tangent. So we're going to go tangent from a 19-degree angle. So it's tan 19 equals the opposite side, which is 10, over the adjacent side, which is x. So now we've got to solve for x, but x is stuck in a denominator. So the first thing I need to do is multiply that x out of the denominator. That gives me x tan 19 equal to 10. Now, I hope you understand tan 19 is a number, but we want to leave it in this form as long as we can because it allows us to stay accurate as long as we can. So now that I have that, I'm going to divide both sides by everything that is not x. That would be tan 19. Your calculator is probably going to put up a parentheses for you, so just fill in your 19 when it does that. So what I would put in my calculator is x is equal to 10 over tan 19. When I do this, I'm going to get an answer. Had a little hesitation there because my calculator was not in degree mode, it was in radian. But when I do this, I get a measure of 29.04, so we will just take the answer 29. Notice my squiggly equal sign because this is approximately 29, not equal to 29. So as we look at this one, and this one we are looking for an angle. So that means when it's all said and done, we will have used either sine -1, cosine -1, or tangent -1. So our angle of reference is pretty clear. Got a big nice question mark here. You actually are not limited to the one you can do here because you could do Pythagorean's theorem and find this missing side, but you're going to have to use a trig ratio anyway, so don't create extra work. So I have the hypotenuse, so I know it's not tangent, so it's either cosine or sine. So as I look at this thing, 21 degrees, or 21, excuse me, is not opposite of this angle. Opposite of this angle is unknown. So this is adjacent and hypotenuse. So as you look through your list, you should see that the trig ratio that deals with opposite or adjacent and hypotenuse is cosine. So cosine of our angle, we'll call it x, equals adjacent 21 over hypotenuse 46. Well, the only thing we need to get the x by itself is to get rid of this cos. Remember, we cannot divide by cos because cos is not multiplication. This is where we have to use our inverse trigs. So we're going to go cos of -1. What we do on one side, we have to do to the other. So I do free up my x by doing this because those are inverse functions. So x is equal to cos of -1, 21 over 46. I'm obviously going to have to take this to my calculator. Can't do that one in my head. And what we learn is x is approximately 63 degrees. What we get is 62.8, which rounds up to a 63 degrees because it does ask us to write it in the nearest degree. So that angle measurement would be 63 degrees. The next thing we're going to need to do tomorrow is to identify if a triangle is acute, obtuse, or right. Don't look at this picture and try to make that distinction because that could be 90 degrees, that could be 91 degrees, that could be 89. You wouldn't be able to tell those with the naked eye, so we're going to put this to the test. Remember our rules. Leg squared plus leg squared equals hypotenuse squared. Well, if they are equal, then it's the right triangle. If they are not equal, excuse me, then it's either acute or obtuse. We'll see which one it is. So 5 squared, of course, is 25. I'm putting actually just like it reads in my calculator because who knows, maybe I'll get lucky and I'll get a nice round number. In this case, I do. 6 square root 3 squared is 108. But don't forget what this is 6 squared times square root of 3 squared. So 6 squared is 36 times 3. That's where the 108 comes from. And then 12 squared is 144. 25 plus 108 is 133. So the small guy's lost. Remember, when the big guy wins, what we have is an obtuse triangle. So this one, man, that looked like a right angle. That's why we don't go based on a visual analysis. Make sure we give a mathematic. And then the last thing we're going to see is just regular old Pythagorean's theorem. Remember, Pythagorean's theorem is leg squared plus leg squared equals the hypotenuse squared. 11 squared is 121. Remember, when a square root meets a square, it's just the number. In this case, that's 65. And then we're looking for x. So 121 plus 65 is 186 equal to x squared. I then take the square root of both sides. So here's a little bit of advice, by the way. This is a multiple choice question. When I put this in my calculator, I get x is approximately 13.64. Well, this is multiple choice on this particular one. What you could do is go through all of these numbers and see if any of these, now this is the answer right here, but if I wanted to see if 2 square root of 14 was a reduced version, I put that in my calculator and what I get is 7.48, not what it's supposed to be. So even if you're asked to reduce, you can always check the answers on this one. This one clearly does not reduce because that's one of the multiple choice answers. But if you're struggling with reducing the radicals, remember, this is a number. Square root of 65 is a number. It's the number 8.06. We don't understand the square root of 65, but we understand 8.06, don't we? So if you're having some issues, change those radicals to numbers, change those trigs, the tans and cosines to numbers, and you can evaluate them with numbers that you are familiar with. All right, so you have the study guide. If you notice on the 4th page, it is the answer key. I want you to be able to look back and see if you got your answers correct. That way you can redo them and see. If you have any questions, we're going to spend the rest of the time working on that. Good luck.